Okay, so you have just come from looking into the formulas for the various solids. You've examined how to use the various formulas to find their volume, and in some cases surface area. So now we're extending that and looking at something called a composite solid. So a composite solid is any three-dimensional shape that's made up of more than one solid. So we can see some examples here. Some are more complex, where others are rather simple. So we're going to walk through in this lesson, in this video, how do you approach these problems? How do you look at a composite solid and find, say, its volume? All right. So we have this problem. We can call this, well, the very first step. Here we go. Very first step is to identify what solids you have. So looking at this, we have a prism, looks like a box, and we have a pyramid sitting on top of it. That's the very first step. All right, guys. Step one, identify what you have and also write their formulas. Step two is understand what you're doing with these two volumes based on the solid. So the pyramid has been placed on top of the prism. So we are going to be combining those two volumes. So mathematically, that we are going to be adding the two together. And I'm going to write that. So volume of our pyramid. We're going to add to it the volume of the prism. Okay. So we're having a game plan. Also, this would be the moment where, let's say I was only looking at half of a pyramid. I would have that included here as well. I'd be putting like 1/2 of the volume for the pyramid. So that's in this line as well, if I have to modify the formula at all. So then our third step is where we're going to spend most of our time, and that's going to be finding the volumes. Okay, so the volume of a pyramid is 1/3 area of the base times the height. Volume of a prism is the area of the base times the height. So we examine this. So let's talk about our pyramid for a moment. So we have 1/3. Okay, area of the base. The base of this pyramid is this, we'll say it's a rectangle. So if this is 10, 10, 8, 8. So the area of that base would be 8 times 10. And then the height of the pyramid, be careful here because the 15, according to this bracket, the 15 is the entire height. So knowing that the height of the prism is only 8, we could argue that the height of the pyramid is going to be 7. All right, so then we're going to add to that value the area of the base for the prism, which is again 10 times 8. And then the height of the prism, which is 8. So we have this. We don't need to modify it into the formulas. So I can type this in all at once. So with our graphing calculator, or even just really any calculator at this point, we can go ahead and type this in. And if you want to do it in pieces, that's perfectly fine. But this can also be done all at once. So watch how I'm going to type it in. So we have 1/3, and we're going to be doing 8 times our 10, multiplying it by the 7, okay? And then we're going to add to that 10 times the 8 for the area of the base, and multiplied by the 8 for the height. And in doing this, hitting enter, just double checking what I have, making sure I have this fraction in parentheses. Okay, we're good. So we hit enter, and we are going to be having a volume of approximately, volume of shape. The volume of our shape is approximately 826.67 centimeters cubed. All right. So going back through the steps again before we move on to the next one. Identify your shapes. Understand what you're doing with those shapes, whether you are combining them or taking them away from one another, and if you have to modify the volume formulas at all. And then from there, using your values, place everything in and find your volume. All right, let's try this on another. So let's say we have, a good old cone, and this is a cone with a half sphere on top. So we identify that we have our cone and our sphere, and we wrote the formulas down. But when we go to step 2, I'm placing this half sphere on top of our cone, so we're going to be combining them, but I'm going to want half of the volume of the sphere, okay? And then we're going to be combining that with the volume of our cone. So here's an example of how I had to modify this formula. So now we place everything in. So we have, in this situation, 1/2 times 4/3 pi. Our radius of the sphere appears to be 2, so 2 cubed. Okay, we're combining that with the volume of our cone, so 1/3 pi radius. So the radius of the cone is the same radius as the sphere, so again that's 2 squared, and multiplied by the height. So the height, according to this, the total height is 7. So that's not the height of the cone. So how am I going to find the height of my cone if the whole thing's 7? Well, this 2, that's the same distance here as well. So if this is 2, then we can argue, well, this must be 5 then, taking the difference of the 2. So then the height of our cone is 5. So this might be a little more complicated to do all at once in our calculator. Let's give it a shot. I am actually going to break this down. I'm going to find the volume of the first. So 1/2, on this side, 1/2, and then 4/3. Notice I'm enclosing each in parentheses, times pi multiplied by 2 raised to the power of 3. I'm only raising 2 to that power. Hitting enter. Okay. So I am going to just write here 16.755, but I'm not going to, I'm going to show you what I'm going to do with my graphing calculator later on. So we have that. Now we have the volume of our cone. So 1/3, and then times pi times 2 squared multiplied by 5, and we're getting a volume of 20.944, okay? And we want to add these two values together, but to be more accurate, in this graphing calculator, I can actually scroll up on my screen. If you can see the blue there, yes you can. I can hit enter, it brings it down. And go scroll up, enter, it brings it down. Hitting enter again, we can find the volume of our shape to be approximately 37.699, and it would be centimeters cubed. All right, so not bad, not bad. So we're only dealing with something that we're combining two shapes. So let's end here with a very, very, very common solid in geometry when we look at three-dimensional shapes. And also this is something that is actually common in, real life. This is a cylinder with a cylinder removed from it. See, there's a hole right there. I could put a little color this in. There's a hole right there. So, like a roll of toilet paper, maybe a roll of paper towels, or a roll of, I don't know, copy paper, or receipt paper. I don't know. It's just a roll of paper with a hole in the center. So when we go through our process, identifying the shapes we only have cylinders. Okay? So when I make my game plan, I have this larger cylinder, so I want to say cylinder outer. We're taking away, so it's subtracting, we're cutting out the volume of the cylinder on the inner. All right, so we don't have to modify the formulas at all. We're not like cutting a cylinder in half or anything. So now we can go ahead and place our values in. So volume of the cylinder, pi r squared times the height, and pi r squared multiplied by the height. Do not assume that the radius for each are the same. All right, that's a very common mistake that we use the radius. Another common mistake is that if we're given the diameter, that we don't do anything with it. We just plug that value in. Diameter is not the radius. So I have the diameter of, so my outer, we're on outer first. The diameter of my outer cylinder is 4 inches, which would make my radius 2. And our height is 6. Okay? So the diameter of the inner, we are told, is 1 inch. So the radius would be, yes, 0.5 or 1/2, and then multiplied by our height. Okay? So do not put a diameter into a volume formula without dividing it by 2. I cannot think of any volume formula that uses the diameter. Most of our formulas involving circles use the radius. Okay, so now we just can place this into our calculator all at once and get our result. So we have, let's see, pi times 2 squared times 6. All right, and then we have minus pi times, let's do parentheses, times pi times 0.5 squared times 6. All right, double checking to make sure everything is good. Everything looks good. Yes, yes, yes. And we get an approximate volume of 70.686 inches cubed. So this game plan I have found very useful. Identifying the shapes that you have, making your game plan, writing it down what you are doing, whether you're adding, subtracting, and whether you have to modify any of the shapes, and then using those formulas, plugging everything in. Okay, double checking what you are typing into the calculator so that you know for certain when you hit enter that you're getting an accurate answer. So good luck, guys, when you go and practice this more. Each shape is really different because they involve different solids and different things done to it. So just stick to this game plan, the 3 steps here I presented to you, and you should be perfectly fine. I'll see you in the next video, and good luck.